Hello students, welcome back. Welcome back to my channel CGAT Maths. Myself Dr. Suresh Brother. In this video, we are concentrating on finding the Fourier series of a function f of x, that is pi minus x by 2 in the interval 0 to 2 pi, the periodic function of period 2 pi, and hence deduce that 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus so on is equal to pi by 4. Very easy one. So first we are going to write the Fourier series. The Fourier series of f of x in the interval, general interval I am writing, in the interval c to c plus 2 pi is f of x equal to a naught by 2 plus summation n runs from 1 to infinity a n cos nx plus summation n runs from 1 to infinity dn into sin nx. The Fourier series and Fourier coefficients. Fourier coefficients are a naught equal to 1 by pi, integral runs from c to c plus 2 pi, f of x into dx, an is equal to 1 by pi, integral runs from c to c plus 2 pi into to 2 pi into f of x into cos nx into dx, and bn is equal to 1 by pi, integral runs from c to c plus 2 pi, f of x into sin nx into dx. Now let us find out a naught, an, bn, and substitute in the given Fourier series. You will get the given equation or given series. You will get a Fourier series. Now let us find out a naught, an, and bn. Okay. Fine. Now let us find out a naught. This is 1 by pi, right, as it is. Here the given interval is 0 to 2 pi. F of x value is pi minus x by 2 dx. Now let us integrate this. Is equal to 1 by pi. So here you can take 1 by 2 outside. You will have only pi minus x. Integration of pi is a constant. Respect to x is pi x. Integration of x is x square by 2. You can also observe integration of pi dx. Pi is a constant. You can take outside. You will get 1 into dx. Integration of 1 is just x. So between the limits 0 to pi. So this is 1 by 2 pi. Substitute upper limit minus lower limit. Pi into x value is 2 pi minus 2 pi whole square divided by 2. So upper limit is over minus lower limit is pi into 0 is 0 and 0 by 2 is 0. So you will get 1 by 2 pi 2. Pi 2 pi into pi is 2 pi square minus 2 pi square by 2 is again 2 pi square. 2 pi square is 4 pi square by 2 is 2 pi square. So 2 pi square get cancelled. Is 0. That is a naught is equal to 0. So now let us find out an, student. Fine. So what is an? An already I have written. An is equal to 1 by pi. So right, integral runs from 0 to 2 pi. F of x value is pi minus x divided by 2 into cos nx into dx. So to integrate the product of two functions, we are using Bernoulli's rule. Bernoulli's generalized formula for integration by parts, that is integration of product of two functions is equal to first function v1 represent integration of second function, differentiation of first function into double integration of second function plus double differentiation of first function into triple integration of second function, and so on. So let us use the formula and evaluate, which is equal to 1 by pi times first function is pi minus x divided by 2 v. This is u and this is v. Integration of cos nx is sin nx divided by n. Differentiation of pi minus x by 2. So here 1 by 2 is constant. Differentiation of pi is 0. Minus x is minus 1. That is 0 minus 1. Again, double integration of cos nx. The first time integration is sin nx by n. You integrate this, you will get double integration of cos nx. That is integration of sin nx by n is minus cos nx divided by n square. So further differentiation of 1 by 2 into minus 1 is 0. We are stopping here itself and substitute the limits between 0 to 2 pi. Students, as you know already, the sine function that is sine 0 is 0, sine 2 pi is also 0, means sine function for upper limit and lower limit is 0. So we are not going to find the value of this. So we are going to concentrate on second term only. So for that, this is minus minus plus plus minus minus into 1 by pi into 1 by 2 into 1 by n square becomes 1 by 2 pi n square. Substitute, it is only remaining cos nx. Substitute upper limit cos n into 2 pi minus n into 0. Upper limit minus lower limit, so which is 1 by 2 pi n square into cos, students, cos 2n pi value in generally is 1 and cos 0 value, cos 0 is also 1, cos n into 0 is 0, cos 0 is 1, 1 minus 1 is 0, therefore an value is 0. Now let us find out bn value. Okay. Let me find out bn value, students. So bn is equal to 1 by pi. Substitute the limit c is 0, c plus 2 pi is 2 pi only. F of x is pi minus x by 2 into sin nx. Use as usual Bernoulli's generalized formula for integration by parts. So 1 by pi, first function pi minus x by 2, integration of sin nx is cos nx divided by n, minus differentiation of pi minus x by 2 is pi is 0, x is 1 divided by 2. Or you can take it to 1 by 2 outside, then you can evaluate. Next, double integration of sin nx or single integration of minus cos nx by n is minus sin nx divided by n square. So next differentiation of minus 1 by 2 is 0. We are stopping here. Substitute 0 to. Further, so the second value becomes vanishes uh, because of the limits 0 and 2 pi. Sine function for 0 and 2 pi becomes 0. So substitute only in the first term. So take minus sign outside. This is 2 into n, also 1 by 2 pi n outside. The remaining is pi minus x. I will write here pi minus x into cos nx. Between 0 to 2 pi. 1 by 2n pi. This is pi minus 2 pi. Substitute x by 2 pi. So cos 2n pi minus lower limit. This is pi minus 0 into cos 0. 1 by 2n pi. Pi minus 2 pi is minus pi. Cos 2n pi is 1. Cos 0 is 1. Again this is pi. Minus pi is minus 2 pi divided by 2n pi. So 2 pi get cancelled. You will get minus 1 by n. Just we need to check. This is as I told you already, here I am going to take this minus sign outside. Just take minus sign outside. So this is minus. So minus minus, this will become plus. So therefore, bn value is equal to 1 by n, student. So now we are going to substitute these values in the Fourier series. Therefore, Fourier series becomes f of x is equal to a naught by 2 is 0 plus summation n runs from 1 to infinity, an is also 0 into cos nx, n is equal to 1 to infinity, bn value is 1 by n into sin nx to dx, sorry, sin nx. Therefore, f of x value is summation n runs from 1 to infinity 1 by n into sin nx. So after getting a Fourier series, students, we need to deduce a required series, that is 1 minus 1 by 3 plus 1 by 5 so on is equal to 5 by 4. Okay. So for that, so what is the substitution we are using? Sine function, when sine function is 0. At first you expand, you will come to know, then only you can substitute. Okay. Expand it. F of x is equal to, substitute n is equal to 1 by 1. N is equal to 1 means sin x. Similarly, 1 by 2 sin 2x. 1 by 3 sin 3x. 1 by 4 sin 4x plus 1 by 5 sin 5x plus so on. So now we can substitute x equal to pi by 2. If I substitute x equal to 0, sin is 0. If I substitute sin x is equal to pi, sin pi is also 0. So for that purpose, we are going to substitute x is equal to that is pi by 2, and observe is f of pi by 2 is equal to Sine pi by 2 is 1, so you will get 1 by 1 into 1 is 1, plus 1 by 2 into sine 2 pi by 2 means 2 into pi by 2, 2 to get cancelled, sine pi is 0. 1 by 3 into sine of, this is 3 pi by 2. What is 3 pi by 2 value? 3 pi by 2, sine 3 pi by 2 value is minus 1, students. So here 1 by 4 into sine 4 into pi by 2, that is 2 pi. 2 pi value is again 0. 1 by 5 into sine 5 pi by 2 is again 1. So I need to calculate f of pi by 2, but I have f of x is equal to pi minus x by 2. Substitute x equal to pi by 2 in this equation. Pi minus pi by 2 divided by 2. This is, can take LCM, 2 into pi is 2 pi minus pi divided by 2 whole divided by 2. This is 2 pi minus pi is pi divided by this 2 comes to denominator, it will become 4. 2 to the 4. Therefore, this is pi by 4 is equal to 1. This is 0. This is minus 1 by 3 plus 1 by 5. This is the required result, students. Thank you so much for watching. We'll meet in the next video.